right, 3 types of homework problems that we discussed in class you're going to see related to the point-slope formula, at least for today's homework. We're given a sentence, the constant rate of change of y with respect to x is 4. Don't be intimidated here. The constant rate of change, aka your slope, is 4. Delta y with respect to 4 delta x. Change of y is 4 times as large as the change of x. That's all that sentence said. Now, 210 is a point on the graph. What is the point slope formula? Y equals m. X minus x1 plus y1. See our last video if you're not sure where that formula came from. We have just a few things we need to know in this situation. Our slope and a given point, aka point slope. That's it. So, y is equal to, what's my m? Oh, it's 4. X minus, what's my first x value? Here's x1, here's y1. Plug it in. 2 plus 10. Done. What's so great about this is that now, here's the point, let's say this is 210. I can find any point. What if I wanted to know when x equals 9? Well, previously we figured out the change in y, we figured out the change in the x, and then we've had to add back to the original numbers. All of that is just included right in here. Here's my change in x. Here's multiplying by 4 so that I can find the change in y, adding to my original value. All I got to do is plug and chug. Y is equal to 4. 9 minus 2 plus 10. 9 minus 2 is 7. 7 times by 4 is 28. 28 plus 10 is 38. That means there exists a point on my graph where the x value is 9 and the y value is equal to 38. So graph that. Here's a point, 9, 38. Could you calculate the change in x and the change in y between these 2 points? Sure. What would you find out? You'd find out the slope was 4. You have an original point at 210, another point at 938. Easy cheesy. Next type of problem you might see in your homework would be that you're going to be given 2 points. Let's try for -1, 5 and 5, 8. You're not told anything else about this, but you're asked to give the point slope formula. Well, remember, we need 1 point, we need 1 slope. Here we have 2 points, we need to calculate the slope. You can either calculate the slope by taking a look at the graph, by using m is equal to the change in y over the change in x and calculating that. So 8 minus 5 over 5 minus -1. In this case, you get 3 over 6. -1, 5, 5, 8. Just another way of showing the same thing. Here's my run of change of x. So this point was -1, 5. This point is 5, 8. 5 minus -1 equals 6. Change in y is 8 minus 5. 3. Rise 3, run 6, rise over run, 3 over 6. Don't forget to reduce. However you decide to set this up, finally I get to an answer of a slope of 1/2. Plug it in. Y equals 1/2. Ooh, which point do I choose? Here's the answer, ladies and gentlemen. It does not matter. Let's go ahead and choose this -1, 5 for now, and we'll see how these are the same. So I'm going to have x plus 1, because minus -1 turns to positive, plus 5. The other option here is you could have set up y equals, here's this guy, 1/2, there's my slope, x minus 5 plus 8. These are equivalent statements. Now let me show you that. How could we figure out that they're equivalent? Go ahead and distribute. You get y is equal to 1/2 x plus 1/2 plus 5. I'm just going to go ahead and turn that into 10 halves here. So I get y is equal to 1/2 x plus 11 halves. Y is equal to 1/2 x minus 5 halves, and I'm going to go ahead and turn this positive 8 into 16 halves. -5, positive 16. Once again, y is equal to 1/2 x plus 11 halves. Ladies and gentlemen, we have the exact same formula. This is a really important problem. Not that you necessarily need to go this far yet. You really just need to stop at the point-slope formula. But what's so great about this is you can see as you distribute that -1/2, this gets us down to the same formula. So it proves the point that it doesn't matter which point you plug into the point-slope formula. And it also shows you how you can go from the point-slope formula all the way down to this little y equals mx plus b. I'm getting ahead of myself, but in a future lesson we're going to see just this, that this is the slope-intercept form of my line. So you can get from the point-slope form to any form of the line that you'd like. It is just great. The last problem we're going to talk about in relation to the point-slope formula is that sometimes you're given a table. Remember, each point in that table is a point on your graph. -4, 18, 6, -12, 7, -15, 9, -21. All points on my graph. You can still find the changes. Remember, slope is the change in y over the change in x. So I'm just going to create a little column out here for my changes. So how do I change to go from -4 to +6? 6 minus -4 is a double negative, so it's really 6 plus 4. This is a change of +10. To go from 18 to -12, I've got -12 minus 18. That's a change of -30. You could do this for any of these values, but in the end, you just need to take the change in y, divide it by the change in x of 10, and my slope here equals -3. From here, it's just a matter of plugging in the values. As we saw in the last video, it doesn't really matter which one is plugged in because when we simplify, it all comes down to the same equation. So y equals -3, x plus 4 minus 18 it was an option, y equals -3, x minus 6 minus 12, y equals -3, x minus 7 minus 15. Any way I do it, it's always y equals the slope, x minus x1 plus y1. Hope that makes sense. Good luck.